All right. Hey there. Let me shuffle some windows around. Share. Let's just do this for now. So hey, I had a long stream yesterday, about 6.5 hours, but I managed to edit it down to about an hour and 40 minutes, which was pretty nice. If you haven't checked that stream out, definitely go check out the previous stream where I was working on the lower levels of the simulated SPI connection for Anachro-PC. Just as a real quick reminder, what I worked on yesterday was coming up with a TCP simulation of the physical layer and the encoding and logic layer. Got that all working, at least to some reasonable value of working. Today, I think I'm going to be trying to integrate the existing client and server that actually speaks the Anachro protocol on there. So that's starting to push up into these layers. So yeah, I'm going to be working on that. I'm going to be working similarly to how I was yesterday, where I drop out. I'll be a little bit more active in dropping out quickly. So hopefully you'll have a couple minutes of me talking in between fast forward motion of me actually coding on some stuff. But yeah, I definitely know I'm going to have to take a look at struct or trait for high-level interface. So right now I have two traits, one for low-level that does the actual like line logic, and the other one that does more of this encoding and logic level stuff. And my original thought was to make that a trait. Now I'm thinking it might need to be just a struct that takes one of these, something that implements this trait. I'm not 100% sure how I'm going to do that yet, but I think it should definitely be possible, and I think there might be room for doing stuff like providing a default implementation of the lower level if you give me an SPI port and some GPIOs, because then I think I could implement it generically for just about anything. The interesting question is what to do for storage. So when you receive like a queue of messages and stuff like that, you might want to use, if you're on a desktop, you might want to use a standard vec or a vec deck. If you're on embedded, you might want to use heapless vec or BBQ. And I'm not really sure how I'm going to abstract over that. I may end up making a trait that's like storage medium, like create new instance and resize, and basically kind of like come up with some traits that go over what I expect to be able to do so that you could use it with the BBQ. But since this talk's pretty soon, so I might just do something that works, and it might be sort of limited, but I'll open up an issue or something that says, hey, this could be way more generic and portable in the future. But I'm currently in let's just make it work mode right now. So as long as it will run reasonably on my hardware, I'm going to be happy with that. So I might just use a BBQ because I know that'll work on both, and let the user change the dial of how big of a storage queue that they use. Yeah, it's times like this I really miss heap allocators, but it's also interesting to be able to do it without one. So I'm going to dive in. I'm going to probably start with the... I'm going to start by just getting familiar with my code again, because it's been a couple hours. So I'm going to dive back in, and I'll check back once I have either a plan or I have something working. So, going to work.
The point was at this time that when I did that, we were speaking about that nothing is really corny if you can find a way to do it.
Okay, so I've been skimming through. I think what I'm going to try and do now is I think I'm going to move the high level implementations that I have that are specific to the TCP stuff right now. And I'm pretty sure I can move all of that to a struct that uses BBQ. And except for like yeah. Okay. Yeah. I think I can do that. And that will let me move some of this into code that I control. So this is what I was talking about in the last video, where there's some of this logic where having it be a trait isn't necessarily great because there's only one right way to implement this, which means I should probably be doing it in the library itself and not as a trait thing, because otherwise people could make incompatible versions of it. So what I'm going to probably do is, I'm going to take the high-level structs that are right now implemented in the TCP connection, and I'm going to move them up into the actual SPI library. And I'm just going to add a hard dependency on BBQ in the SPI library, and that'll be good now. And if someone wants to make a generic over a VEC or something instead of a BBQ, cool, power to you. But I'm going to do it with BBQ now because I basically wrote this with BBQ in mind anyway. I'm a little worried I'm going to end up with like 9 BBQ instances by the time that I get to the actual application, but that probably makes sense depending on like one for each SPI port, or if you have a UART or a radio or something, if you're doing your protocol over not SPI. I'm going to introduce BBQ. I'm going to wire this up. I'm going to move the structs up. Probably I'll introduce BBQ here, get the logic right, then move it into the actual SPI crate. Then maybe I'll actually just publish an instance of the SPI crate and do it all at once. We'll see, but I'm going to get back to work.
Feathers don't shine brightly in the moonlight. I don't know how to sing a pretty song. Like water off a duck's back, you seem to slip away. Well, natural selection be damned, I'll be okay. I used to think I'd wanna be a bird of paradise, but now I'm happy being just a quail. I think I'd wanna be a bird of paradise, but now I'm happy being just a quail.
Okay, so I have made some good progress. It's been a little bit, but I've got the arbitrator totally switched over to using BBQ now, and the functionality is still the same. I can still run this. Let me make this a little bit bigger. So I can still send and receive messages, so I'm pretty happy with that. It is using, oh, well, I go to demo, and why do we have an in-grant already? I wonder if it got out of order, but I will go check on that. But, you know, when it doesn't crash, it does seem to work. So I'll go chase down that bug, but that's why I have panics and asserts everywhere. But yeah, so I'm pretty happy with this. I'm going to take a quick break either way. Nah, looks like it fails after a little bit. I was only testing it, I wasn't testing it long enough apparently. So I need to figure out, this is probably on abort. I'm not releasing the grants the way that I'm supposed to. So I'll look into that. Yeah. So that's going well. So my next step is to, well, fix these bugs, figure out probably in the abort logic how to release the grants, because it's probably just getting confused that things aren't getting cleaned up properly in an abort. But then I'm going to go do the same thing for the client. And then I'm going to try moving the struct up to the SPI crate. So I'm going to go ahead and take a quick break now. So I'm just going to play some music. I should probably check on the chat. No one said hey, so no worries. So I will go ahead and take a break, and then I'll be back to implement this for the client as well. Thanks for watching. Well, I'm excited. I went to the kitchen to make some coffee, and my wife was making dinner, so instead I have wine, because wine is a lot like coffee. So cheers, and I'm going to get back to work. See you in a bit. Okay, not too much to share, but I have the client now working as well, so they're happily talking to each other, which means now I just need to start yanking all of this code out of the individual applications and back up into the library as a top-level struct. So, yeah, I'm going to keep working on that. It's going well. Hopefully I'll get that done before I go to stop to have dinner, but we'll see. But Yeah, I don't think there's anything really crazy that's happened. It pretty much went exactly as expected. There was a lot of copying and pasting. So things are going well. So, on to making this a library. Okay, I'm still working. I got the arbitrator code moved over, but seriously, I'm just super excited about how easy that refactoring was. Like, be compare head. Like, the fact that I just moved, um, all of that with like absolutely no problem, and now the code is totally portable and can work on literally any target that implements the low level protocol is crazy to me. Like I just completely removed like all this code and just moved it immediately over into a generic structure in SPI arbitrator, which now, well, I'll just look it over here because the diff's not. Well, no, let me do that. And then let me show you the difference between SPI and PC examples, arbitrator, SPI, TCP, source, main, and arbitrator. So, I mean, like, no, I want to quick compare. But, like, basically all of this code is the same except for I needed some different error handling. And that's basically it. Like, only thing I had to change. And now the type just takes a AnkLogic LL arbitrator, so it's generic over literally anything that implements the low-level arbitrator. I'm just super excited about this. You're probably not as excited about this as I am, but I'm very excited. So I had to pause and show you that. But now I'm going to go do the exact same thing for the component, because it should be literally just as easy. And then, yeah, then I need to plug it into the actual high-level protocol, so like the pub sub protocol. And then I might even get to actually putting it on hardware today. We'll see. Maybe that'll be next stream, but I'm super excited about that, and that went super well. This is going to be a good diff to look at. Okay, back to work. Okay, I'm excited again. It just took 5 minutes. Super excited. It's when you prototype things right and then they click into place the way that they want you to. It feels really good. But yeah, I'm gonna actually wire this up to the protocol, I guess. Huh. All right, let's go. So I'm looking back at my client and my arbitrator code because I wrote just like I haven't actually looked at the client and arbitrator code for the actual protocol layer in a while. And I realized I did actually split this up into 2 layers. I have a trait for client IO that sends or receive messages. And then I actually have the logic. So this is actually really similar to the pattern that I was using before. I should have been intelligent enough to remember that and remember that this is the style that I write. But I'm actually really pleasantly surprised because I think that I can do this really smoothly because in the actual example client, PC example client, TCP, a good chunk of this code is all just like receiving chunks of messages and processing state and things like that. It's worse in the arbitrator or the server code. But essentially this goes away because I can add a blanket impl of client IO for SPI TCP. So, well, okay, it's a blanket impl of, let me pull it up because this is going to be easier. And let me make the code a little bit bigger so you can actually see it. So I have 2 things. I have the low level, which is a trait. Not this. This is gone now. I have the low level trait, which says like, how do you actually encode stuff on the wire? And then I have a struct that's the high level of that essentially just gives you the ability to NQ and DQ messages. And you have to pull it. And if you look at the actual client IO code, it's looking for a trait that's able to receive and send. And that's it. So, I mean, like, that is literally my NQ and DQ messages here, which means I can add a blanket impl of client IO for enc-logic HL component, which means all you have to do is, and I'll probably move the like TCP SPI connection into the actual SPI crate too, because there's no reason for everyone else to implement it themselves. It'll probably be behind a feature, like a TCP feature or something like that. And then I guess I can move like an embedded HAL one next to it, because I'm going to end up having like an embedded HAL one, so like physical SPI. But yeah, I think actually modifying this, I need to figure out where to make the cuts. But when I make the cuts, essentially all I'm going to have to do is, like, I bet you in server, there's probably server, source, lib, I guess. Oh, no, right. Server's cursed. Client's going to be easy. Server, I wasn't able to cut it up, but maybe if I used the same like owning pattern, because here you have to provide the messages. The client, the high level client doesn't actually own the client IO. And I wonder if that makes the lifetime problems that I have with the arbitrator easier to handle. So I'm definitely going to do the client first because the client's easier because the client has a better division. It might be the wrong division, but I wonder if I just keep using this pattern all the way down, and this is essentially how I encode network layers. That for network layers, essentially, so let me come back to my face a little bit. Let me make this really ridiculously big so it's visible. So I have thoughts on network layers. So, I mean, I have like 6 levels. So let's just call it like 6, 5, 4, 3, 2, 1. And like on each of these levels, if I have a trait and a struct, like assuming this is the whole stack the whole way up, that essentially this level actually doesn't get one. I wonder if this is like the pattern that I'm using is basically just like this implements this all the way up at every layer of the network protocol. Because then I get to be generic over everything. And as long as someone provides the impl, so like this would be like the concrete protocol layer would be essentially the implementer of this. Because, for example, I have like TCP SPI client, which on the next level up implements, which the trait here is the ANC client component SPI TCP. No, I want the one that's just component. The actual trait here is, I'll just steal this. And up on the next level, I don't know what the trait would be. But the actual struct is the high level component. Which implements, well, I guess I don't have a, is it just every other layer? Because the next layer, the trait, I actually, no, it's going down, isn't it? Concrete impulse go down. Okay, so this is actually more like this struct implements this trait. because the Anch logic LL component is implemented by the Anch logic HL component struct. But at this level, this struct is essentially going to implement well, I guess the trait at this level would be the client IO, because, well, no, I guess it is just like every other layer, maybe. Struct is going to take care of the high level component. And then the next level is actually a trait, because I have the, here's where I have the client IO, and Anch HL component is going to implement the client IO trait. And then I have a struct at the next level, which is client, which doesn't actually, I guess this isn't the next layer up. This is at the same layer, because client, yeah, I guess if I'm using the same like ownership, I guess I am putting this at a different layer. And this is where it's actually going to get, I don't know exactly what this layer is. This is going to end up being something like, see, I receive, what do I receive from the client? I receive messages. So if I actually go and look at the client code, the client, what does the client give you? Client lets you create a new one, get ID is connected, but basically it's publish and subscribe, or publish and receive. So that's really like application layer, I guess. I mean, I sort of have the like logical topics app protocol. But this is like not even structs. This is just like a router. And then this is like user applications. This is some routing stuff. I don't know. But I mean, like, this is interesting because I've essentially alternated every layer between structs and traits. Because this is also a struct. And then essentially everything just kind of like walks up. But the thing is, the user only really needs to define the top and the bottom of this, which is, I guess, generally what I want. They can mix and match at these levels, which is good because, for example, if you had like a client that was connected over both SPI and wireless, then you'd want to mix and match this, where like the top level is going to be the same, but you might have multiple I/O providers. This is interesting, and I don't really have a good like layer diagram. So this is, let's see if this matches what I was saying before. So I mean, like, TCP SPI client does think how to provide an SPI copy kepo clock. Logical LL component. This mic is bothering me. Logical LL component. Logical HL component would be SERDE postcard encoded data. I think these don't line up. Client level. Okay, let's. Because this is actually like 7 layers. So I'm off by 1 somewhere. Yeah, I guess I have like... I guess I have 1 more here. Five, four, three, two, 1, 0. Physical. I guess this is just Anch. And this is Anch logic. And this is client IO. This is just client. And then routing, I guess. Yeah, I mean, I guess that's my, I don't know, I guess that's my network layers, but it's interesting that it always ended up being an alternating trait struct kind of thing. I'm sure this will click to me at some point soon. I don't know why. It feels like I've accidentally into a very good setup. Well, I think I'm going to go eat dinner. So I'm going to put the stream on pause, and I'll be back in a bit, and I'm going to start tackling the client. This is going to be interesting because I have to get them both. Well, I was going to say I have to get them both updated, but I suppose I could update the old application client to talk to the new application server. And they should work because they're speaking the same protocol. The server's not going to be able to respond or whatever. It's just going to like print messages because it doesn't actually understand like the connection negotiation logic. But it'll be able to speak the line protocol and be like, hey, I got a message that happens to be like a session negotiation request, which is actually going to be pretty straightforward to check as long as it can negotiate individual messages back and forth, because it'll just send some garbage back. Like the new server will send garbage back. It'll just send like 4444 or 15151515 or whatever it is. But it should be pretty straightforward to test. And then I wonder if I'm going to end up needing to take a step back and look at the server code and see if there's an intelligent, clever way that I can squish that down. Because that was one of those things that I didn't have a good way of abstracting the server well before. And I may have just been going about it wrong. I wonder if I can apply some of the patterns I used here on the lower level, because theoretically, all of this is pushing all the way down because you should only need to store these messages in one place. Okay, well, I'm going to go eat dinner, and then I'll be back, and we'll see if we can do something with this. Okay, I'll be back in a bit. Okay, I wanted to complain. I thought this was going to be really straightforward. I went into the component. Where am I looking for? I'm looking for component RS. I was like, hey, all I need to do is DQ a message. Problem is I made everything 0 copy, which means like passing through multiple layers is a nightmare. And I was like, okay, that's fine. I'll just cheat. I'll just clone it and I'll come back and I'll clean it up later. So I wrote this monstrosity, which is me attempting to clone this deeply because I didn't have clone methods plumbed all the way down and I wanted to see if this would work first and then basically extract this into clone methods for each of these items. But I realized that in one of the cases I have a payload that's just a slice of bytes. Like, it's just a slice of bytes. There's no way I can clone this without a heap. Which means I feel like I need to do one of two things, and that's either like introduce another layer where I can copy it into, like just processed payload packets, but then I'm essentially introducing like a new BBQ or a heapless vec, I guess, maybe, of whatever the payload is. Or I return the message with like the grant attached to it so that it's valid. They're valid as long as each other. But then the problem is if someone ends up holding on to one of those messages, then like you can't continue processing new incoming messages while you're holding that grant. Which means like if you hold on to it and do nothing with it, it's going to look like you never received any messages ever again until you release that. Because it'll keep saying like, hey, grant's already active. I understand why TCP stacks use allocators now, because following this up and down is just a nightmare. I don't know what I'm going to do. I want to look at those two different options. The first one's going to be just like break it off so that you get some kind of reference to it. I could introduce the with pattern again, but then I have to do all the deserialization stuff on it, which is a nightmare. I don't know. It went so well at the lower levels when you're just shuffling bytes around. Once you start actually thinking about data types that borrow, it starts getting gross. This wasn't supposed to be a stream about lifetimes. Oh well, let's see if I can smash it up. Okay.
Obsolescence feels complete. I'll turn off all the lights and I'll close all the windows. My desktop is clear and I'm out of here. My cache is blasted, a thing of the past.
So I remember how I got around this last time, and it's essentially in the high level component. I just hold on to the grant, and then I just release it the next time I try and receive something. And this works because essentially this just makes sure that you can never borrow. It ties the lifetime of the grant to the lifetime of the high level component, which means essentially before you do anything else with a high level component interface, you have to have dropped your message, or at least dropped your reference to the message, which works surprisingly well. But I remember that I wasn't able to do this on the arbitrator side because the arbitrator side is more complicated. So I'm going to push through here, at least on the client side, see how far I can get. The answer might be I need to overhaul how the whole interface stuff works. Or I need to get more aggressive in terms of queuing messages level to level, but that might be challenging. But I guess I could use a VAC. I don't know. We'll see. Because the problem is you could have drastically different sized messages, like some messages that are 2 bytes and some that are 2 kilobytes. And if you put those in like a heapless vec together, then they're all going to be the same size, which is going to be awful. We'll see. I'm still making progress. I'm still figuring stuff out. I need to um I need to move the TCP code from the I'm starting to fade. So it's getting close to the end of the day for me. I am going to try and at least get the client working though before I call it a day. Excuse me. And then maybe take a look at the server and see how bad it is. And maybe just so I can start my brain thinking for how I'm going to overhaul that. But I'm going to go with this for now. It's actually not that bad. But yeah, I'm going to run through it. Okay, I'm going to move the TCP code up to SPI behind a feature, and then I'm going to switch my client over to using that instead of the line protocol that it already has, and I'm going to try and get it to talk to the new server. It might work, it might not. I mean, it's definitely not going to work, but it might sort of work. Because it's not going to negotiate the protocol because the new server doesn't know how to speak the protocol. It just sends garbage messages. But if I can get it trying to negotiate and exchanging messages, then I'm pretty pumped about that. Or if it sends a message, I'm pretty pumped about that. So I'm going to go ahead and try and do that and then probably call it a day. Because now that I've got food in my belly from dinner, I am starting to get tired, or at least losing my ability to focus on hard lifetime problems like this. But it has been a productive day still. So I'm going to go back in, clean some stuff up, see if it works, contemplate more crazy lifetime stuff, and then get back at it. So here I go. Okay, so I've been going for like 6.5 hours now with some breaks, but I'm reaching about the end, but I did get some success. So here I have the new TCP server, so the one that does all the like SPI simulation stuff. And here's the old client, which is wired up entirely into the TCP, or entirely into the pub/sub protocol stuff. And I've switched it over to now using the components that come from SPI directly. So if I start up the new server with the old client speaking the new protocol, we can see every second the client actually successfully negotiates the sending of a message, where this is it trying to connect. It's trying to say, hey, I would like to connect to the server, please. And every time the server sends a message back every 10 seconds, it's a parsing error because it's just a garbage message. But this is bidirectional communication over my fake SPI, which means the client is totally working and the server still needs some love. But I've reached the end of my mental ability for today. So let me go through. I actually want to see a couple diffs of this. So let's compare these contents real quick. So in particular, I want to look at the client TCP. So we can see that I added in a dependency on the Anachro SPI and BBQ. I'm going to have to clean up like how I manage my dependencies and stuff like that and what I re-export so it's not super gross. I think I'm going to have like a dependencies module in each crate that just exports like the BBQ and postcard versions that they use so that if you don't want to include all of the crates, you can just get it from the dependencies. We'll see. But the actual code's the more interesting part because if you look, all I essentially did was rip out the old IO handler. And I just replaced the old IO handler with the one that comes from the SPI crate, the one that I've been working on all of today. The one hack that I had to put in there is right now you have to pull the state machine. It doesn't just update itself. I think right now this was running in a separate thread or something. I can't even remember. It's too late. But I need to plumb this poll back down so that it just does it when like someone's asking for messages or something. It'll just process incoming messages. So there's two places I had to add that. But other than that, the client code hasn't changed. And it's still speaking the entire pub sub protocol, which is awesome. And then looking at SPI... Well, we can also look in component SPI TCP because I got that working first. Essentially, I just deleted everything. All this code now lives in the SPI repo because it's a generic SPI over TCP. And then the rest of the code didn't really change. So I just removed some of the imports because I don't need them anymore. And now I import this from the Anachro SPI crate. So that works super awesome. TCP basically just grew... Excuse me, that's the wrong one. SPI grew a new TCP module, which is essentially all the code that I just ripped out of the other one. I did have to bring in some more dependencies for that. Again, I'm going to have to fix that. Let me actually just go ahead and remove this now because I don't want to check that in because otherwise I'm not going to remember to remove it. And then I just have like a TCP feature that gates that. So if you're running on no standard, you wouldn't pull in the TCP feature. I also wrote up a big comment that explains how the lifetimes for this work. I'm actually super excited about it. If you follow me on Twitter, you've seen me now yelling about it. But the fact that I can take an incoming message, take it all the way up the layers of my stack, generate a reply message, bring that all the way back down, and never have copied the data is bonkers to me. I'm super impressed that the borrow checker can figure that out, and that it can do that safely. So, yeah. On one hand, it's kind of gross because it makes it hard to work with, and if someone wants to copy a message, it's going to be kind of a pain. But honestly, that's kind of... them's the breaks. So, I just realized my... well, okay. Other than that, not much changed. I deleted some code. Yeah. Pretty pumped about it. So, yeah, I think that was a pretty successful day. Again, kind of like yesterday, didn't make it all the way to where I wanted to end up, but I actually got a lot done and kept a pretty good pace going. So thanks everyone for watching. If you want to watch the full version of this, it's like 6.5 hours. I'll put that up on YouTube as well. It's going to be a lot of me. All the parts that are normally fast forwarded at 16 times are going to be much slower. And I'll probably do some shorter, not 6.5 hour streams during the week this week because it's just super convenient to work like this. So I'm actually probably going to do this fairly regularly. But thanks everyone for watching. I hope you enjoyed. Feel free to reach out on Twitter or YouTube if you have any questions, and I'll see you for the next episode. Thanks everyone.